Okay, let's look at a real life use of a function. Okay, a farmer has 16 metres of fencing with which to make a rectangular enclosure for sheep. If one side is x metres long, show that the area A is given by the function a of x equals 8x minus x squared. Draw a graph of the function a of x in the domain x between 0 and 8, and then use your graph to estimate the area of the enclosure when x is equal to 2.5, the minimum possible area, and the values of x when this occurs. Sorry, that should be the maximum possible area, the maximum possible area, and the values of x occurs, and then the two values of x for which the area is 12 metres squared. Okay, so here's the solution. So we draw a rectangle, okay, and we know that one side is x, okay, so we'll call the other side b. And when we consider a rectangle, often we consider the perimeter of a rectangle and the area. Okay, we know that the perimeter is given by this side plus this side plus this side, which is x, plus this side, which is b. So it's x plus b plus x plus b, which is 2x plus 2b, if we gather the like terms. And that perimeter, the farmer has 16 metres of fence to work with. That's all equal to 2x plus 2b. And if we divide every term in the equation by 2, we get 8 is equal to x plus b. So b must be equal to 8 minus x. Okay. Now, when we consider the area of the rectangle is x multiplied by b. Okay. We know what b is. It's 8 minus x. We can sub that in, and we can show that the area is equal to 8x minus x squared. Okay, so that's that first part. We've proved the first part. So, okay, let's plot this function a of x equals 8x minus x squared, okay, in the domain x is between 0 and 8. And if you put that into your calculator, we have our x values and we're y equals f of x values here. Because sometimes you'll see y equals f of x written that way in the exam. Okay, and a plot of that yields these points here, or if we plot those points, we get our parabola, which we would expect from the quadratic. Okay, and we're asked then to solve different parts of the problem. So one part was to find the area of the enclosure when x is equal to 2.5. So we come out, x is 1, x is 2.5, and across, and we get the area equal to 13.75. We're then asked to find the maximum possible area and the value of x when this occurs. Okay, the maximum and the value of x when this occurs. So the max area is here. Okay, so it's at A area equal to 16, and this is at x equals 4. We can see that from the table, but we can do that mathematically. If you remember, we can find that maximum turning point by using x equals minus b over 2a, where minus x squared plus 8x is our quadratic. If we just rewrite it this, a is minus 1, b is 8, so that would be minus 8 over minus 1 by 2, and that's x equals 4 if we were to plug that into the equation. Okay, so that's the value of x where you get the maximum area. Okay, so if we have one side equal to 4 and the other side equal to 4, then he's used up 8 meters of fencing here and here at x equals 4, and that means he's 8 meters left, 4 either side, 4 fours are 16. That's the maximum area. Okay, and finally then the two values of x for which the area is 12 well, this is our area here. We go up to 12, okay, and we strike a line through, a equals 12. We drop a line down and we see that those two values for 12 are at x equals 2 here, x equals 2, and x equals 6. Okay, where these two intersect at x equals 6. We'll have it there. And that's a real life application of a function.